start the recording now. Okay. Right. So we'll start today on transaction log basics. Anytime you have any questions, you can stop me because this is one of the important concepts in SQL Server and one of the most important concepts. So anytime you feel you have any questions, you can stop me. So what all we're going to cover today is I'll talk about what is transaction log, and then I'll talk about what does it actually store and how the DB changes are made to the database files. What is the process, which is write ahead process, and the concept of rollback and roll forward. Then I'll also talk about the processes which write data to the database files. Then what are the different types of checkpoints? So once we look at the checkpoint process, I'll talk about what are the different types of checkpoints we have. What is the active and inactive portion of SQL transaction log? And then we'll move on to recovery models. And then I'll talk about the virtual log file, which is basically the architecture of how your transaction log file is arranged. And then just some best practices on how to configure your log files. And then I will just talk about, we'll have a demo, a quick demo on see all these concepts. I'll try and show you as much as I can today. There's a lot of concepts, a lot of theory today, so just bear with me for some time. And if you have any questions, just stop me, right? So let's get started. Okay, so what is transaction log? So I will take an example of it's like a scratch pad. So if you remember it being in college, right? So your professor would teach you on the board, writing on a blackboard or a whiteboard you had, and you had a pad where you would make quick notes, right? So whatever he's teaching you, write it, and then you would go home and write it on your fair book or a notes book, right? So the one on the board, you can assume it is like your transaction log in the memory, and then your scratch pad could be log on the disk, and your fair book is your MDF or the NDF file that we have. So it's basically a transaction log is the scratch pad in which SQL Server writes what all changes to the data is being made at any point in time. So any updates, inserts, and deletes, anything. So there are two transaction logs. I should not say transaction logs. The one in the memory where is scratchpad in the memory is called the buffer log, and one on the disk is called the transaction log file or the LDF file. So what is the purpose of this transaction log? Why do we need it at all, right? I think that is the question you should get in your mind. Uh, why should you write it to a memory and then write it to on a page? So what it provides is the durability. So I'm sure you might have heard of ACID properties for databases. This is for the durability. Basically, what it means is any transaction, anything that happens on the database, either it should be fully there in the database or should not be. So it should be committed fully or not committed. So this transaction log helps us provide that feature, and we look at that how it does in the coming slides. So let's go that. Okay. So I'll just talk briefly about what does it actually store. So a transaction log will store, or a buffer log will store what is happening on your server, all the insert, updates, and deletes. What is the data got changed? It will keep in before image. What was the data before it changed? What is the after image? So if it's an update, what was updated? What column, what rows were updated? And what time did it happen? And was it successful? So I'll keep it very simple. This is what it requires. I will not talk about log sequence numbers and everything. This is just to keep simple to give you an overview, and more you can read, and is quite simple. So that's all it is. And then I'll talk about the write hard logging. So this is a very favorite interview question people will ask you. Uh, what is write ahead logging? So what SQL Server does is, so you have your data pages in RAM and you have your SQL update. So when you begin a transaction, when you update, the data is written to the buffer log in the RAM. It is not directly written to the disk. Why that is done? because writing to disk is slower and writing to your memory is faster. So it will first write to memory and then it will write to the transaction log on disk. And from there, it is basically hardened onto your data files. So this process where the changes on the database are written from the RAM buffer log to the transaction log on disk. This is basically write-ahead logging. And this is what is the process SQL Server will use to improve the performance so that your database performs fast. And also to provide you the durability property that I talked about. And so in case of a outage on your server or a restart on the server, so we should have all your transactions. So this is what is right of logging. I'll just stop there. Any questions anyone has for this? Okay. So next I'll just talk about basically a rollback and roll forward concept. But this is the main concept. I will take an example. So you go to a bank and you're withdrawing money. So I'll come back to this page. So you withdraw your money, you do an update. So you will have a table where your data is stored, right? It will say you have balance of 10,000 and you withdraw, say 1,000. And that will first be written into RAM and immediately written to your transaction log file here. But you are here somewhere. I didn't draw that. Sorry for that. You're somewhere here. You don't get the money and power goes off. So I'm sure you don't want that transaction to be written, right? So because you didn't get the money because it's not completed. So it's SQL Server didn't get back acknowledgement that is completed. So when it comes back up again, when your server restarts, what it will do is it will look at the transaction log on disk. Sorry, here. Here it will look in this transaction log and see that this is the transaction I started, but I didn't commit it. So what it will do is it will roll back. So it will not undo that transaction. So that is the concept of your rollback. Uh, does that make sense? Is it clear? I just stop because this is a very important concept. Right. So that is in case of the transaction was not committed. So for example, I'll take another example. So you do the transaction, you get your money, but that is not written to this. Let's go back and try and understand the diagram. So you do an up, it does an update on the table and write this to the data pages, all the transactions that you have done, whatever 1,000 rupees or whatever you have withdrawn is written to the RAM. That's written to the transaction log on disk, right? And then you get the money and you acknowledge that it is committed. So it will write that transaction is committed here in the transaction log on disk, but it has not been written to data file yet. It's not hardened as it's called. So, and then power fails. So now, if the power comes back, what would SQL Server do? Can you guess about what it will do? So anyone wants to just say what it will do? Right. So, okay. So what it will do is now SQL Server has written that I have committed this transaction and acknowledged. It is in the transaction log file on your disk, and it will then harden it to the data file and say, yes, it will roll forward. That is the process is called roll forward process. So it will roll forward all the transactions which were committed and it will roll back all the transactions which were uncommitted. So that is the process it will do SQL Server and it will use the transaction like file on the disk to do this process. So this is what provides the crash recovery in case of failure. In case of power failure or any kind of failure for a SQL Server. So when it comes back, it checks this transaction on there and rolls back, roll forwards any transaction which have not been committed. Rollbacks which have not been committed and roll forward which have been committed. So this is the concept of roll back and roll forward. Any questions on that? All right. Okay. I was never so sure that I'm so clear. Anyway, let me go ahead. Okay. So what are the processes that move? So now we have seen the data is being written to memory, and then it is being written to transaction log file on disk, and then it is written to your MDF file. So what are the processes which move this data around? The first is the log flush process. This what it does is it writes both committed and uncommitted transactions from memory. Memory is the buffer log to the transaction log file. So it will write both. So whatever. So if you have a long running transaction, maybe you're updating 100 million rows, it will take some time. So the log flush process will run. It will write how many rows have been modified into the transaction log file on disk. That is what it will do. It will do both committed and uncommitted. So that is the important part. And how often it runs depends on how much memory you have in the system and the recovery model. The second important process is the checkpoint process. This is the process which writes all the committed transactions from memory to disk. So like I talked about the money that we had to withdraw, right? You got the money. This is committed, right? So in that case, it will write all the committed transactions from memory to disk, and also whatever transactions we had in the transaction log on file on disk, it will write to the MDF file. So this is the process is called hardening. So this is where your data is being hardened onto your MDF files. So checkpoint is the process which will do this. There is no other process in SQL Server which will do that. So you have to be aware of this checkpoint process, which is very important. So that's how these two processes help writing data to the disk. So the difference is the log flush will do both committed and uncommitted, while checkpoint will do only committed transactions. So that's the difference between these two processes. And so next, what are the various type of checkpoints? There are first one is the automatic checkpoint. This is again, there are three in them. So you have the time based. This checkpoint will run at regular intervals. It is a configurable value in SQL Server. This is basically, you can configure it by using the recovery interval value. So if you go to SP configure and choose that, and you can change that. Default is 0, which means a checkpoint will occur every 60 seconds. So you could reduce it if you want to. So recovery interval basically means how much time SQL Server will take to come up when you start your SQL Server. So if you reduce the time, it will try and flush more logs so that it has more data to recover, shorter data to recover, and more data is on data files. So if you reduce that, but then your performance will go down, and the default value. So that is what you can do. The other thing is log size threshold. So based on your transaction log size, it will run your checkpoints. And the third point is the dirty page threshold. So what is a dirty page? A page which have been modified in memory, because as you might know, SQL Server will get all the pages, AK pages into memory, make the changes and put them back. So whatever changes which have pages which have changed are called dirty pages. And so if you have a lot of dirty pages, so that you can recover it quickly, SQL Server will have a threshold and do a checkpoint when that threshold crosses. Then there is an internal checkpoint that is based on events like backup, and when you do a snapshot of the database or you do a shutdown of the database. So before shutting down, SQL Server will run a checkpoint. So all your transactions from your tlog file will be returned to your MDF file. Also, when you run a backup, when you run a transaction log backup or a full backup, it will do especially in a transaction log backup, it will do a checkpoint, write all the committed transactions from your tlog file to the database file, and then do a backup. So the database is in consistent state. Then there is a manual checkpoint. It basically means when you run a checkpoint command. So there is a tsql checkpoint command you can run. I'll show you how to do that in the demo. So any questions anyone has? I'll just stop there. No. Okay. Okay. So let me go next. So again, another concept is the active and inactive. So this is very important because sometimes I'm sure you might have had a problem where you're trying to shrink the transaction log and it doesn't shrink. So you should understand why it is not shrinking. So the active part of the transaction log will never be truncated. So uh, keep that in mind. What is the active part? It is the part of the transaction log which has the uncommitted transaction and which have not been committed or rolled back. So this cannot be truncated. So just keep in mind that, and I'll show you how can we find once we do the architecture of the transaction log. I'll show you how we can find. There are some commands. How can we find, and that cannot be truncated. And the active, sorry, inactive part of the transaction log is the one which has been committed, has been returned to, has been committed. It might be in transaction log file. You run a checkpoint, it will return to your MDF file, and that is what can be truncated. So you can shrink that part of the transaction log file. So in a typical scenario, if you have a long running transaction log, sorry, not transaction log, a long running transaction, and your transaction log is getting filled, there is no way you would be able to shrink your transaction log file. So, and your disk might get full, and then your operations might get affected. So you need to understand what is active and inactive transaction. So this is the concept of active and inactive transaction. Okay, let's go ahead. Okay, I'll just quickly talk about the recovery models in SQL Server. There are three recovery models. One is simple. So this keeps the first one is simple one. It keeps minimum transaction information. It doesn't keep a lot of information. The inactive transaction log is truncated at checkpoint. So a checkpoint will occur with default of 60 seconds. Whenever a checkpoint will occur, it will truncate the inactive part of your transaction log. The transactions which have been committed, it will just truncate it. So in now you cannot do a point in time recovery because you do not know what transactions have happened. So because it's just truncated there, the inactive portion of the transaction. So you cannot take a transaction log backup in simple recovery. Just remember the recovery model just decides how often your transaction log gets truncated. It has nothing to do with your crash recovery. So there are two, sometimes you get confused that in simple, when the server comes back, it will not be doing any recovery. It will be doing any recovery, it will be doing recovery and rollback and roll forward. So in simple, the only difference is you cannot do a point in time recovery using transaction log backup because you cannot take transaction log backups. In full, this is the most comprehensive. It records all the informations, all inserts, update, and deletes, everything. So, and you can do point in time in the recovery, and the transaction log will be inactive portion will truncate only when you take a transaction log backup. So it will not be an automatic process. So if you have a scenario, you put a database in full recovery model and forgot to set up your transaction log backups, you're in for a big trouble because your transaction log file will keep growing, keep growing, keep growing, keep growing until it hits the disk. And so just be aware that if you set your database in full recovery, remember to set up your transaction log backup. Otherwise, your log will never get truncate. Then the third is bulk logs. Okay. So can you mute yourself if you're not talking? Okay. The third one is bulk log. So the issue. Just let me try and guide one second. Sorry. Okay, sorry for that. Then there is, so for example, what is the problem with full recovery model is if you have a lot of bulk inserts, you're inserting a lot of data. Every row, so if you're inserting 1 million, every row, every insert will be written into transaction log, and that will slow down, and your transaction log will be too big. So what you can use is a bulk recovery model, which is in between simple and full. So all what he was telling SQL Server is ignore writing my bulk transactions into the transaction log, and other transactions will be written. So so if you say select star into or something like that, it will ignore. It will not write those into transaction log. So they will not be available there is a crash and it will not be recovered or rolled forward. So that is the bulk locked recovery model. So I'll just take 2 minutes. Like I'll just ask any questions anyone has, anything at this point. Right. Okay. So I'll move ahead. Right. I'll just talk about virtual log files. This is another important concept. So what happens within a transaction log file? The physical file, maybe you have 10 GB of file or something like that. Within the file, it is internally divided into smaller chunk files called virtual log files. These are smaller logical files. These are called virtual log files. And so when they are created, whenever you create a physical transaction log file, they are created and their size. So, so if you give 10 GB of transaction log file, you created a new database, created a new file, and you gave it a 10 GB transaction log file. So SQL Server will decide dynamically how many virtual log files it wants. So it will just decide on its own and create that many number of virtual log files. We cannot control that. It is not user configurable setting. There is nothing like that. And then what happens is all the files will be of the same size. They will not be of different size. All the files that will be created. So it will calculate, I want this many files. Each file will be this size. So all files will be same size. Then once when we shrink the transaction log file, these virtual log files will also disappear. And the amount of physical file you can shrink is the size of the virtual log file that was initially created. So if you have a 10 GB file and your virtual log file that SQL Server created initially was say 500 MB, so you'll not be able to shrink your transaction log file beyond less than 500 MB. So that is what is there. So sometimes you might have seen that you're trying to shrink the transaction log file, but it would not shrink beyond a point. So that is the point it would not shrink beyond. And only virtual log files which have no active transactions will be truncated, will be shrunk. So you cannot go and say, okay, just shrink. It will not shrink anything which has active transactions. That's because it will need that for recovery, right? Any files which are unused, which have been committed, will be used again. So for now, the important thing here is to remember if you have too many virtual log files, it very slow down your recovery. So what SQL Server will do once it shutdowns and comes back up again, it will read the virtual log files, all of them one by one, and see if there are any committed, uncommitted transactions, even if they are not active. So it will read that. And if you have too many files, then it will take a long time. I had a client, they had around 2,000 files on a database, and it took 2 hours after a crash that this database was in recovery mode, and we couldn't do anything, right? You can't do anything when it's in recovery mode. So you have to monitor your virtual log files. I will show you the procedure, which gives you how many files are there, and I'll show you how you can monitor and what you can do to set that up. So I'll give you another, how can you reduce that also. So that's the virtual log files. Okay. So how do you end up with so many? So if you have a very small log file size and auto grow is also very small, you will have too many virtual log files. And what happens is if you have a smaller log file growth, each time you grow your transaction log file, your operations will be halted. So you will not be able to do anything, and your users will complain, right? Uh, this is the recommended size. There is no fixed size or rule that how big your transaction log file should be. I like to keep it around 25%. This is what we learned from our mentors. So this is what we usually do. And the other thing is log files are written in sequence. So there is no point having multiple log files. So if someone says, oh, I have multiple log files, there is no point in having because there is no performance gain you will get. So SQL Server will fill first file first, and then if you have another file, it will start filling the second file. So there is no performance gain there. And autogrow for transactional database, it is recommended to have 1 GB if you have an autogrow setup. And virtual log files, acceptable range is 50 virtual log files per 10 GB of database. Anything more than that, then you need to consider fixing that issue. Otherwise, you'll have issue when you do a recovery, right? So, any questions anyone has? Okay. Anything anyone wants to ask? Okay. So I think so. I've covered whatever I. So I'll just quickly go on the demo. So we have 10 minutes left. So we'll try and do the demo and then we'll join that back again. So let me go back. This is okay. So this is my SQL server I'm connected to. I have two databases, my test one and my test three. So what I'll show you first is the rollback and roll forward, how we see that. So I can see that. Okay, so I'll explain what I'm doing. So let's do, and there is a table. So I'll just drop this table in my database. Okay. Okay, so let me just connect it again. Let me move this. Sorry. It's not connecting. Let me try. Okay, so I've dropped that table. I've created one table. This is just one column, two columns. One is the ID column and the string value. So I'll just create that column. And now what I'm doing is I'm trying, I've declared an integer I, and then I'm inserting 100. This is, yeah, trying to insert 1 million rows into that table. So I begin the transaction. I am saying begin transaction and begin, and I'm trying to insert, and this is the end. I've not committed my transaction. I'm not committing this transaction here. So what I'll do is I'll run this, start this, and then I will shut down my SQL Server, and then I'll show you what SQL Server will do, and we can check that in the error log and see how it will do a rollback. So we'll just run this. Okay. Let's create the table first. Okay, create this table. Okay, sorry. Okay, so it's already there. Let me drop it again. Let's create a table. Okay. Let's run this. Okay, so this is this. Okay, so I'm running this. Okay, it's running. Now I go into my configuration manager and I will restart my SQL Server. Okay, stopping. So you can assume that we're power off kind of situations. I'm just shutting down, stopping the service and starting it again. Okay, this. Okay, so that's stopped and start. Okay, started. So now if you see, this is disconnected because I stopped the SQL Server. And now if I go into my error logs, let me go refresh my error log and open the current one. Just maximize this. So if you see uh, here, it will say one transaction. I'll just maximize this part also. You can see. So that was a transaction that was going on my test. So it is just rolled back that transaction because it was not committed. So that's how SQL Server will do a rollback in case your transaction is not committed and power goes off. You have a problem with your server. So that's how it will roll back that uncommitted transaction, and that is what it did using the transaction log file. So this is how it will be. Uh, can we shall we? Okay, so one more thing. So this is the rollback, and I'll show you the roll forward thing. So let's go into that demo. So let's close this one. Okay. So roll forward. Okay. So now I'm doing a similar thing. So on the same database. So let's connect this. Okay. So what I'm doing is I'm just inserting the same table 100,000 rows. I'm sure you know this. If you give 10,000 or any number in front of Go, it will execute this batch that many times. And as you know, each insert will be a implicit transaction. It will commit each one of them. So we'll run this and then we'll start the server again and see how roll forward works, because in this case it is committing each row insert, right? So when the power goes off and it comes back, it should roll forward whatever changes it had done, right? So this is what we'll see. So we'll just run this. Let's run this. Okay. So it started. So it started inserting the rows, and I go back. Okay. And let me restart my SQL server. Okay, so that's what it is done. Now again, this is disconnected, but now it has inserted some rows. These were many rows, and these should be because it has said it is communicated to the client that they have been made, changes have been made. So it should do a roll forward. So if I just refresh my transaction now, okay, and go in here, okay, and I should go down. So it will here, if you see, this 17 transactions have been rolled forward. Let me maximize this. So 17 transactions rolled forward in so in my test data. So that's the roll forward. So anytime SQL Server, if you start and go into error log, you'll see for each data bit, it will say these many transactions, it has roll back and roll forward. So this is the recovery process that SQL Server will go through whenever you have a restart of a server. Uh, so sometimes you will see the recovery is taking too long. You cannot do anything. You have to wait till it is completed. So that's how it provides the recovery mode. So we have 3 minutes left on this meeting. So what I have few more demos to show. So shall we drop now and join back again? Is that fine with everyone? Or anyone has any questions? We can take some questions for 3 minutes. Am I audible? I am not sure if I guys can hear it.
Yes, yes, you are audible.
Okay. Shall we drop and join back again? Or because I have two more things I want to do, 2 or 3 things I want to show. So I'll stop this meeting and I'll start again. You guys can join in. So we'll do that. Yeah. Okay. So I'll just stop the share and uh, end the meeting. So you can join when in a minute. So I'll start the meeting again with the same link. So, okay. Just